Right, so now we're on to section 8.3, and it is using the double angle formula. Now again, there is rules that you can use. They're in the log tables again. They're on page 14 again, so they're these ones on the right hand side. Actually, they're on the left hand side as well. It's just different forms of the same thing, so you can write it in different ways. But the ones we're going to focus on for this bit is cos 2a, sin 2a, and tan 2a. Cos 2a is 1 minus 2 tan squared a. Sin 2a is 2 sin a cos a, that's grand. And tan 2a is equal to 2 tan a, 1 minus tan squared a. Okay, so they're the ones that we're going to use now in the next couple of examples. So in this example it says express sin 3a in terms of sin a. So we have to try and manipulate this so it just has sin a's in its answer. You can't have any other answers. You can't have sin 3a because that's not the same as sin a. So what I'm going to try and do is change this using what we've already done to try and look like sin a. Now if you think about it, 3a is the same as 2a plus a. So we could write sine of 3a is actually sine of 2a plus a. Now what have we got here? Sine of an angle plus another angle. So that is actually kind of like sine of a plus b. Similar to what we've done in the last. Now using the log tables we can actually check that sine a plus b is actually sine a cos b plus cos a sine b. So that's what we're going to go for down here. Okay, so sine a is sine 2a, that's okay. 2a sine 2a multiplied by cos b, but in this case b is actually a, the second angle, plus cos of the first angle, cos a, the first angle in this case is 2a, multiplied by, I'll put brackets around this, multiplied by sine b, and b in this case again is the back angle. Now if we expand these two, sine a or sine 2a and cos 2a, from here we can change things slightly. So I'll actually drop another line. Sine 2a is actually 2 sine a cos a. So we have 2 sine a cos a multiplied by cos a. That's okay, we've just replaced this together, plus cos 2a is 1 minus 2 sine squared a. So again, square brackets, 1 minus 2 sine squared a multiplied by sine a. So this square brackets is this 2 sine a, this square brackets is this cos 2a. Now if we multiply out here as normal and we multiply out here as normal, we get 2 sine a cos a multiplied by cos a. The two of those multiplied together will give me cos squared a. So 2 sine a cos squared a plus sine by 1, or sine a by 1 is sine a, minus 2 sine squared a is actually 2 sine cubed a. I will get back to this bit in a second. Sine cubed, I'll do it on the side. Sine cubed a is actually sine a cubed. So in reality we actually do have sine a. It's just slightly different. It's just written a bit easier so you can work it out. Okay, so we'll go back to that now in a second. This is sine a, that's grand. Cos squared is causing a bit of a problem. Sine a is okay, and sine cubed, as I've just shown over here, is okay. So we just have to change this. But from one of the first proofs that we showed, cos squared is actually 1 minus sine squared. So we can change that to 2 sine a multiplied by 1 minus sine squared a. Okay, so just change this to this. plus sine A minus 2 sine A cubed, if that makes it just a little bit easier. We now have another multiplication, so multiply that out. 2 sine A by 1 is just 2 sine A. 2 sine A by minus sine squared A is actually minus 2 sine cubed A plus sine A minus 2 sine A cubed. And now we've actually rewritten it, because as I've shown a while ago, sine cubed can actually be written as sine A all cubed. This is sine cubed A, which can be written like that again. So we actually now have 2 sine A minus 2 sine A cubed plus sine A minus 2 sine A cubed. And we can combine the numbers, adding like terms. 2 sine A plus sine A is 3 sine A. Minus 2 sine A cubed minus 2 sine A cubed is minus 4 sine A cubed. Done. So in the last example in this section, in this part of the this section, I'm going to do example 2. It says, given that theta is an acute angle and that tan theta is 1 over 2, evaluate sine of 2 theta and sine of, or cos of 2 theta. So we have to try and work it from there. Now the first thing I'm going to do is, we have tan, we have sine, and we have cos. So what I can do is make a right angle triangle. Sine, cos, and tan, and it says it's acute, so this angle here is going to be theta. Okay, now tan is opposite over adjacent, so this side is going to be opposite, which is 1. This side is adjacent, which is 2. We have a right angle triangle, so that means we can use Pythagoras Theorem. So with Pythagoras, we can work out that this angle here we'll call x. X squared equals 1 squared plus 2 squared. X squared equals 5. X equals root 5. Okay, so from that now we can extend that sine theta is actually going to be opposite over hypotenuse, which is 1 over root 5. As well as that, we can work out that cos theta is actually adjacent over hypotenuse, which is 2 over root 5. So now we can work out our sine 2 theta and cos 2 theta from these two identities, or these two proofs. So the first question we're asked is sine 2 theta. So if we go to our double angle formula, sine 2a is 2 sine a cos a. So in this case, sine 2 theta is 2 sine theta cos theta. That's a theta there. Sine theta is 1 over 5, 1 over root 5, multiplied by cos theta is 2 over root 5. That's over 1. If you multiply them all together, 2 by 1 by 2 is 4. Root 5 by root 5 is root 5 squared. Root 5 squared is 5. So final answer, sine 2 theta is 4 over 5. And the second one, cos 2 theta, almost the same thing. Cos 2 theta from the log tables is cos squared a minus sine squared a. So we will use that. Cos squared theta minus sine squared theta. Cos squared theta is 2 over root 5 squared minus sine squared theta is 1 over root 5 squared. Squaring those out, 2 squared is 4, root 5 squared is 5, take away 1 squared is 1, root 5 squared is 5 again, 4 over 5, take away 1 over 5 is 3 over 5. So final answer, cos 2 theta is equal to 3 over 5.